Here we have a very useful formula known as the difference of two squares formula. It's a squared minus b squared equals a plus b, a minus b. Okay, so this is something that you should probably internalize because you'll see this all the time as you go about factoring various binomials. It only works on binomials, that is two terms, and it needs to be a minus here. It doesn't work for plus. Okay, and this could also be, it could also be written as a minus b, a plus b. The order there doesn't matter. Okay, so let's try it out. Here we have x squared minus 36, right? So we could look at this as x squared minus 6 squared, and this is indeed of the form a squared minus b squared. All right, so the formula holds here. X plus 6, x minus 6. Right? It's a very easy formula to use. These binomials just fall right apart. Okay, let's try this second one. B, we have 169a squared minus 49b squared. This is a little bit more going on. All right, so we want to write this as something squared minus something else squared. Let's see here. 169 is actually 13 squared, so let's write this as 13a quantity squared minus, well, 49 is 7 squared, so how about 7b squared? All right, now it's of the right form, a squared minus b squared, and we know that the formula tells us it's going to be a plus b, a minus b. All right, so 13a plus 7b times 13a minus 7b. There we go. And you could also swap these two entire terms. You could switch the order. You could have the minus first and then the plus. That'd be just as good. All right, here we go. 16x squared plus 25. And you may already be thinking, okay, 16 is 4 squared, 25 is 5 squared. I'm going to stop you right there. This is plus. This formula doesn't work on plus. It only works on minus. So here we say prime. Prime. Now, just like a prime number doesn't factor into any smaller numbers, a prime polynomial doesn't factor into smaller polynomials. So this means that this is as good as it gets. Now, if we added the imaginary number I to the field of numbers we're working with, then this thing we could make this factor. But we're not working with I yet, and at this level, usually we just call this prime when it's a binomial with a plus like this. Okay, let's try this fourth one, D. Here we have, okay, 49m squared. The thing about this one is, note that 1 is always actually 1 squared. This is a perfect square itself, right? And so sometimes you can just jump straight to the answer with these. You don't need to go through all these steps. So here maybe you can see it already. It's 7m plus 1, 7m minus 1. There we are.